Imagine walking into a factory where almost nobody works, because the workers are robots. But here's the strange part. Those robots are building other robots.
For most of industrial history, the rhythm of manufacturing was dictated by human hands. Even as machines grew larger and more powerful, they remained tools that required people to guide their movement and manage their output. That human presence is now extracted from the physical production line. In these environments, the surge of heavy machinery often takes place in total darkness. Hundreds of robotic arms move through pre-programmed arcs, while autonomous platforms navigate the floor below, delivering parts to specific stations without any manual intervention. The assembly line has transitioned into a system that operates and maintains its own physical workflows. A factory of this scale is typically designed to produce consumer goods, like consumer electronics, everyday household appliances, or commercial vehicles. But the components moving along this track are different. These are high-torque actuators, structural steel limbs, and heavy-duty mechanical joints. One robotic arm reaches down to secure a heavy gear housing, meticulously assembling the frame and joints of another industrial machine. This process represents recursive manufacturing. The factory is now functioning as a system designed to replicate its own internal components. The first phase of this replication focuses on the structural integrity of the machine's physical frame. Automated welding rigs fuse heavy steel plates together, creating a skeleton capable of withstanding massive loads. Once the frame is secure, precision arms install the high-torque motors and planetary gear sets that will eventually provide the new unit with its range of motion. This requires high-density mechanical coordination. Several robotic hands work on a single chassis simultaneously, with one group holding a component in place, while another drives the securing bolts to exact torque specifications. Autonomous mobile robots support this by timing their deliveries to the exact second a specific motor or gear is required by the assembly arms. Constructing this physical shell is the foundation for the complex systems housed within the machine's interior. As the metal frame is completed, the assembly shifts to the installation of microscopic electronics. Specialized tools thread an internal network of circuit boards and microprocessors through the chassis, creating a digital nervous system. These systems integrate with optical sensors and motor controllers. Raw environmental data enters and is filtered into a structured spatial map. This data stream completes the loop back to the central processor, allowing the machine to correct its movements in real time. Integrating these cognitive systems transforms the assembly from a collection of parts into an entity capable of autonomous operation. The process enters its final phase when the newly manufactured machine is powered on. The unit executes its boot sequence, activating its cameras, rotating its head housing, and testing its finger articulation through their full range of motion. Instead of human technicians conducting the inspection, the factory uses a specialized array of quality control cameras to scan the new robot as it moves. This system evaluates the calibration of every motor and the accuracy of every sensor, ensuring the unit meets the precise tolerances required for the factory floor. By automating the evaluation process, the factory removes the need for human oversight during replication. Expanding the view across the facility reveals a floor populated by hundreds of these machines, all operating without human presence. When a robot passes its final autonomous test, it immediately takes a position on the line, contributing to the assembly of the next generation of machines. This creates a self-feeding cycle. Traditional manufacturing follows a linear path of production, but when machines build the machines that build them, the output shifts into exponential growth. The facility has effectively transitioned into a self-sustaining system of growth and replication. The emergence of recursive manufacturing suggests a future where the entire logic of global supply chains is redefined. Human contribution is shifting away from the physical act of building. The role of the engineer is now focused on the architecture of the systems rather than the individual products. The focus of modern industry has moved toward engineering the machines that will autonomously build the future.
If you found this interesting, give this machine a signal. Like it, subscribe, share it.
And stay tuned. The machines are only getting started.